Hello students, welcome you all in Solanki classes. Today I am here with a new topic, accuracy, precision and errors in measurements. So let's start with accuracy. The closeness of measured value to the true value of physical quantity is known as accuracy of the measurement. So let me explain it. So this is the true value. True value means the exact value of any measurement. Like we are going to measure a length of a line and its exact length is 7 centimeter. But when we are measuring it with a scale, when someone is measuring it 6.9, another one is measuring it 6.8, someone is 7.0 and another one is 7.1, like this. These are the observations. If these observations are very close to the exact any true value of the observation, then we can say these measured values are accurate. This is called accuracy. जब measured values आपकी वो exact result के काफ़ी close होती हैं तो हम उसको accuracy कहते हैं. We can take one more example. Suppose we have a glass slab and we are going to measure its length, and its exact length, that means the true value of the length, is 5.98 centimeter. Suppose this is the exact length of the glass slab and we are measuring it with the vernier calipers and we have some results like 5.85, 5.91, 5.92, 5.9. These are the measured values. But if you will see that these values are not close to the exact or the true value of length of the glass slab. So what we will say that these measured values are not showing accuracy. These are not accurate measurement. This is called the accuracy when we are measuring something and our measurement, our observed values are very close to the true value of the physical quantity, then we can say that our result is accurate. And which one of the exactly equal or the very much near to the true value of the physical quantity, that will be the most accurate measurement. Like in the first example, we can see this one is the most accurate measurement because it is exactly equal to the true value. Now come to the second one, precision. Precision means the how close measured values of a physical quantity by an instrument to each other. It means whatever we are taking observations, they should be very close to each other, then they are showing the high precision. It's not necessary they should be near to the true value of the physical quantity. जितनी भी हम ऑब्जर्वेशंस ले रहे हैं ऑल शुड बी वेरी क्लोज टू ईच अदर, वो एक दूसरे के क्लोज होने चाहिए. ऐसा ज़रूरी नहीं है कि वो सारे के सारे आपके क्या हों, ट्रू वैल्यू के क्लोज हों. We can take one more example. Like again we are going to measure the length of glass slab as we have taken earlier. The length of glass slab, exact length of glass slab is 5.98 centimeter, but the measurement which we are taking that are 5.90, 5.91, 5.92, 5.90 and again 5.91. We are getting these observations. So we can say these observations are very close to each other, even some are repeating also, but they are not very much nearer to the true value of the physical quantity. So in this case what we can say, they are not accurate, but they are they are showing high precision. They are highly precise observation because they are very close to each other. If the observed values are very close to each other, so they are precise. But it's not necessary that if they are highly precise, then they will be accurate also. So we can see these things here. An observation having high precision may have low accuracy, like I have told you here, or the following cases may be possible. Like here we have two different colored dots. The red dot showing the real value or the true value, we can say true value of a physical quantity, and the blue dots are showing observed value. In the first graph, if you will see that this is the true value and this one is the observed values. Observed values are very close to each other, they are very much nearer to each other, so we can say it is a highly precise observation. तो ये हाई प्रिसीजन को शो कर रही हैं, बट दे आर वेरी मच फार अवे फ्रॉम द ट्रू वैल्यू. So what we can say, they are showing low accuracy. So this is the case when high precision in the measurement with low accuracy. But in the second case, if we will see, then we can see that the observed values are close to the true value, but they are not very close to each other. So in this case, what we can say, that this is these observations are showing low precision with high accuracy. In the third one, if you will see, all the four blue dots very much far away from each other. So what we can say, they are low precision. They are showing low precision and they are not very much close to the true value of the observation. So we can say it is showing low accuracy also. In third graph, we can see that all the four dots are not very much close to each other. Four blue dots, they are not very much close to each other, so they are showing low precision and they are not very much nearer to the true value of the physical quantity also, so they are showing low accuracy. So in this case, we have low precision with low accuracy. But in the last graph, we can see that all the four dots, they are very much close to each other. Blue dots, they are very much close to each other, so they are showing high precision and they are very much close to the red dot also. That means the true value of physical quantity, so we can say they are showing high accuracy also. So this is the case when the result is showing high precision with high accuracy. Okay. Now this is very important result, that higher the precision in measurement, higher will be the significant figure of the same. For example, we are measuring the length of a wire, metallic wire with vernier calipers, and one is giving information that the length of the metallic wire is 4 centimeter and another one is giving information that it is 4.00 centimeter. So this result is more precise because it is giving information about the 2 decimal places, and this is less precise because it is not giving any information after decimal places, and it is more precise, that's why it has, we can say it has 3 significant figure and it has only 1 significant figure. So this is the main thing, that higher the precision and higher will be the significant figure in the measurement. So this is very important thing. Now come to the error. Now what is error? Error है क्या actually में? Error in the measurement of physical quantity is defined as the difference between the true value and the measured value of the physical quantity. Like we can write this as a formula, that error is equal to true value minus measured value. True value means exact value, जो भी आपकी किसी भी physical quantity की होती है, and measured value is whatever we are getting after measurement. So errors we can define into 2 types. First one is systematic error, which is further divided into various parts, like the instrumental error. Instrumental error, it is the error which is caused due to the faulty instrument. अगर आपका इंस्ट्रूमेंट ही faulty है तो आप जो भी उससे रीडिंग लेंगे वो आपकी क्या होगी, गलत ही आएगी. So whatever error you are getting in your observation because of a faulty instrument, that is called instrumental error. For example, as I have taken here, we have these two figures. अगर इन दोनों फिगर्स में हम देखें तो जो हमारा पॉइंटर है it is not coinciding with the zero mark. In the first one it is one place ahead, and in the second one we can say it is one place back. So whatever reading we will take from these two instruments, that will not be accurate. अगर हम फर्स्ट को यूज़ करेंगे तो हम एक प्लेस आगे रीड कर रहे हैं, और अगर हम सेकंड को यूज़ करेंगे तो हम वन प्लेस पीछे रीड कर रहे हैं. दैट मीन्स इन बोथ द केसेस वी आर नॉट गेटिंग exact or the right measurements. Now the third example, I have taken a scale whose zero mark is not visible. So if we are going to measure the length of a line or anything else with the help of this scale, then most probably the measured value will be wrong, because we don't know the exact position of zero mark. So these are known as the instrumental errors, which comes or arise from the faulty instruments. Now come to the personal error. Personal error आपकी होती है due to the carelessness of an observer are known as personal error. If the observer is doing some carelessness, showing some carelessness and not performing experiment properly, so these type of errors will arise. Like for example, I have taken one here of pendulum. Like this is the motion of a pendulum. Pendulum is going this side, right side, and then left side, right and left, in this way. If one student is going to count the oscillations of the pendulum, then most probably he will count when it is going right 1, going left 2, again going right 3, again going left 4, in this way. But this is not the correct way. This is not the correct way of counting the oscillations. So if any student is not counting the number of oscillations of a pendulum properly, then the error will be there in the measured quantity. So the right way of counting the oscillations is like this is a pendulum. This is a one oscillation. First it is going in this way to A, and this is B point, B to A, then A to C, and then C to B again. This is known as one oscillation. Then again we can count the second one in this way. This is second oscillation. So we should count in this way. If you are counting in this way, then the whatever we are going to measure related to pendulum, that will be correct. Most probably it will be correct. But if you are not counting in this way, if any one of you is going to count in this way 1, 2, 3, 4, 5, 6, then this is not a correct way. Then definitely the result will be wrong. So these type of errors are known as personal error. Okay, the next one is natural errors. The errors arising due to change in conditions of the environment are known as natural errors. For example, if we are going to measure an experiment at two different places, like we are measuring the resistance of a wire from Ohm's law, and we have two different places, one my own place, that is in Himachal, and another one in any plain area. So we know that the temperature difference will be very high on both the places, especially in summers. So what we can say that if one student is performing in plain areas, then the temperature will be more. Because of that, the resistance of the wire will be greater. And if another student is performing at my place, then the temperature will be low and the resistance of the same wire of the same length, same thickness, identical wire we are taking, and that resistance will be low, because resistance changes as the temperature increases. Resistance increases even when the temperature increases. So in both the places we are performing the same experiment with the same wire, with the same instruments, everything we are taking same, but still we are getting different results because of the temperature difference. So these type of errors, whatever we are getting, that is natural errors, because maybe whatever is the exact value of the resistance in plain areas, it may be higher than that, and in my place it may be lower than that. So maybe the difference will be there, and these type of errors whatever we are getting, these are known as natural errors. The last one is imperfection in experimental techniques. What is this? Let's see. The error in the measurement also arises due to the imperfect technique used for the measurement of a physical quantity. For example, we can see here we are going to measure a height of a or the length of a pen. We are just putting a scale along with it, and if we are measuring the length of this pen from this place, this is the correct angle, बिल्कुल उसके हम सामने से measure कर रहे हैं, then we will read the exact value. But if we are going little bit this side or this side, then definitely we will not measure the right value, it will be this one. So we will read little bit less. If we are measuring from this side, so it will be in this way, and we will measure it little bit greater. So if we are doing this type of mistake during measuring the things, then these things are known as the imperfect techniques of measurement, and because of these things we can get the errors in our results. The second one is random error. Whatever types we have read, that all from the systematic error. Now come to the next one, random errors. Random errors आपके पास होती हैं. These errors are due to unknown reasons or sometimes called chance errors. These errors are not constant in magnitude but variable. They may be positive or negative. So these errors, that's why these are known as random errors, क्योंकि because these are the chance errors. अभी है, थोड़ी देर बाद नहीं होंगी, अभी थोड़ी ज़्यादा है, थोड़ी देर बाद कम हो जाएंगी. तो इस टाइप की चीज़ें होती हैं. We can't find out the exact reason behind that. तो that's why we can say they may be positive, they may be negative, or sometimes may be zero, कि error ही ना आए आपके पास. So these errors can be minimized by taking a large number of observations and then take arithmetic means of these observations and gives the most accurate value of the measured quantity. So this is the main thing which we should remember, that errors can be minimized by taking a large number of observations and then take arithmetic mean of these observations. Whatever mean you are getting, that will be considered as most accurate value of the measured quantity. So let x1, x2, x3 up to xn be the observed values of a physical quantity during several measurements. Thus, the most accurate value of the physical quantity is given as quantity is given as like mean of x means x bar, we will denote it by x bar. This is equal to x1 plus x2 plus x3 up to xn divided by n. So x bar will be the most accurate value of the physical quantity. So x bar will be the most accurate value of the physical quantity. The next one is least count error. First of all, I'll tell you about the least count of an instrument. It is the minimum value that can be measured by a measuring instrument is known as least count of the measuring instrument. For example, like we have meter scale, and what is the smallest length which can be measured by a meter scale? That is 1 millimeter or 0.1 centimeter. So its least count is 0.1 centimeter or 1 millimeter. In the same way, if we are taking vernier calipers, so its least count is 0.01 centimeter, and for screw gauge it is 0.001 centimeter. So different instruments have different least count. So least count error क्या होता है? The least count error is the error associated with the resolution of the measuring instrument. Means if we are going to measure a length with meter scale and the same we are measuring with the vernier scale, vernier calipers, so the length measured by vernier calipers will be more accurate than the meter scale, because vernier calipers will give us information about the 2 decimal places, and whereas the meter scale will give us information about only 1 decimal places. So we can say the length of a rod measured by a vernier calipers is more accurate than the measured with a meter scale. So this is the least count error that depends on the number of resolution of the measuring instrument. This is all about today's lecture. I hope you will like it and it will be more informative for you. Thank you, and we will meet again in the next one.